Hello everyone, my name is Ernesto Flores, and today I'm going to be talking about the inclined plane. In this video, I'm going to be talking about how I'm going to explain the experiment and how I'm going to do it. And sorry that I don't have a face cam in this video because in the laptop I don't have a webcam. So in this video I'm just gonna be talking without the face cam. So let's begin. In this project, it's going to be about the study of the inclined plane. One thing that I did was to do a procedure which was measuring the movement of three different objects and its time values. Then I analyzed the values by hypothesis and also had to use the independent variable, which is the position of an object, and force, the dependent variable, which is the time value, and the control variables, which are the angle, weight, and friction, to calculate the measurements and to get the results. In this inclined plane experiment, I choose two different questions related to variables to get an idea, to make a hypothesis, which was very important so that I can analyze the experiment to see if the hypothesis was true. As for me, in this report, I obtained the information by these questions. The general research question was, can three different objects have the same time values in the same measurement? And the second question was, how the measurements and the weights will affect the time for each object. For the hypothesis that I used and that predicted the answer to the particular research question on this project was, if I could compare the time values obtained from the inclined plane experiment of the three objects with an angle of 30 degrees, they will share some time values with the same measurement. In the experiment, the number of measurements will be 11 to calculate the time of the speed of the object once it reaches to zero on the board, to compare them to see if the time that the three objects have obtained for each measurement, they're going to have a different value that the others have obtained after the speed of the object, after the speed of the objects. In this case, the 11 measurements that there will be to do the experiment are one, I mean are 0 0.05, 0 0.1, 0 0.12, 0 0.15, 0 0.17, 0 0.2, 0 0.25, 0 0.26, 0 0.3, 0 0.32, 0 0.35, and 0 0.39 meters. In the experimental methodology, the first thing that I did was to use a method to avoid changing control variables, which was building an inclined plane with a plank that had to be lean on a table, wall, desk in such a way that the angle between the floor and the plank were constant all the time, and that the plank does not slip. Then I used three objects. In this case, the three objects were a variety, a pen, a plastic marble in all rows. Next was to drop the objects one by one and to take care to avoid throwing them, so that the friction, mass, and size will still be the same in all tests. Materials. The materials to use to do the inclined plane experiment can be a plank, a cover, and any material long enough to be placed on a table or wall, or wall, and to make the distance measurements on it. The objects can be a ball, a marble, a spherical object that is not hollow. In this case, the materials that I used to do the experiment were a tape, a ruler, and a board. As for the objects, as for the three objects, I used a plastic marble, a pen, and a battery. Measurement, recording, and analysis. During the process to obtain the information and measurements, I had to measure the independent variable and the dependent variable. The way of how the independent variable have been measured was to use a measuring tape or ruler to measure the different distances from the end of the board to each of the points from which the object will be released. The way of how the dependent variable have been measured was to measure the time, and in order to do that, I had to use a stopwatch, a cell phone, or an online application. The range and number of measurements of the independent variable that were used to measure the time on the board were 11 different distances from the edge to the bottom of the board, and once they given the result, the units, which are the centimeters, I converted them to meters. Studied variables. When the results were given, which were taken by doing the experiment, then I organized them in a table, and it also had to include the units of measurement. Then an Excel document had to be made to calculate the results along with the table in a graph. The first column was the independent variable, and in the second column the dependent variable. The, the table must be titled distance travel versus time. It must be numbered, and in the first and second columns it must have the name of the variable, distance travel, time, with the units of measure meters and seconds to calculate and organize the data. In this project, eight graphs had to be made to calculate the process and and to see if the hypothesis was correct. In this case, I created three distance travel versus time graphs for each one of the three objects, which were the first, second, and third graphs. And were also the graphs of the dependent variable on the y-axis against the independent variable on the x-axis, and the distances were put on the x-axis and time on the y-axis in the three graphs for each one. After finishing the first graphs, I had to develop a theoretical model showing a relationship between the distances used in the board and time, which is the fourth graph. I had to make a graph where I have to find a train line from the experimental data and the equation for it, and then I had to try the different trending lines in the graph and choosing the one that most closely matched the data contribution. After finishing the theoretical graph, I had to compare it with each one of the graphs with the three objects data to see if the theoretical graph shares the same time values with the three objects, and those were another three different graphs, which were the fifth, sixth, and seventh graphs. In the eighth graph, I had to create a data comparison graph where I have to superimpose the experimental data of the three objects with their same distances and the time values that were obtained in the experiment. I also had to compare the trend lines between the three objects data to see if one object shares the same time value with another, with any of the other objects. Okay, so now that I explained how did I did the experiment, and how did I obtain the procedures to calculate all the data that I obtained by doing the experiment. So in the next slides, I'm going to show you the graphs and the data that I have by doing the experiment. So at what is showing in the graph, these are the procedures that I obtained by doing the experiment. All the distances that I used to obtain the time values in in the experiment, by using three different objects: the battery, plastic marble, and the pen. So in the next in in the next page, I'm going to be I'm going to show the graphs that that I use to calculate the procedures. Okay, so here are the experimental data graphs. Well, not the complete ones. These are just the graphs of the plastic marble and the battery. So as you can see here, I I, I use the data that I obtained by doing the experiment, and then to well I use them to do these graphs to see if I can obtain a procedure in which I can, well, to see if the hypothesis that I mentioned earlier was correct. Okay, as you can see here, here are the other two graphs that I used to find if the hypothesis was true. Here it is, the graph of the time values of, of the of the object that was the pen. And here is another graph that is the theoretical model that I used to compare the the graphs with 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 this one to see if they share some time values, and to see if they have some intersection points and all of that. So how do we analyze all of these four graphs? Well, after finishing graph 1, 2, and 3, we can observe a trend line in each of the graphs, which is not adjusted to the data because of the data for having different values that are their distances and measurements. Even though they have the same distances, they will still have some different time values. For for the fourth graph, we can observe the behavior of the theoretical model using one of the kinetic equations for the inclined plane, which is t equals to 2 plus x divided by g elevated by 0.5, which is affecting the values and being different from the ones on the first three graphs. And the trend line looks more adjusted because the values are increasing correctly from smaller to larger from symmetric way, and the shape is not linear. It looks more like a square root function for having different distances in the time section values. As for the theoretical model, the data comparison graphs, which are the battery, the pen, the plastic marble, well, as seen on the three graphs, the similarity between them is that they don't share with the theoretical graph a time value. As you can see, the time values and the distances which they have, they, they are not exactly, well, they don't share similarities between the data with the theoretical graphs. So which means that they they don't share any data. Comparison data graph. As we can see in the comparison data graph, the difference between the three data of the three objects is that they almost don't share the same time values. Although they share the same distances, they will still have different data and the different time values. The similarities between the three data graphs is that they share some time values, value points in the same distance except for the battery data graph. The plastic marble and pen data share some time values in the points of 0.11 meters on 0.36 seconds and on the 0.35 meters on the 0.8 seconds. In conclusion, in the experiment it looks like that the hypothesis was not true from the results given in the tables and from the graphs that has the time values of every distance for the three objects. What happened in the experiment is that the data of the time values with the distances of 0.05, 0.1, 0.12, 0.15, 0.17, 0.2, 0.25, 0.26, 0.3, 0.35, and 0.39 meters of the three objects that were a plastic marble, a pen, and a battery. But at the same time, they share some time values in different distances. The data points that shared the same values with the other objects were the plastic, marble, and the pen, in which their points were 0.11 meters at 0.36 seconds and 0.35 meters at 0.8 seconds. For the comparison of the three objects data with the theoretical graph for each one, the experiment for the graphs was to see if the three objects also shared some distance points with the theoretical graph. And after doing the graphs, it turned out it didn't share value points since the time values of the theoretical graph were too far from the ones of the three objects. And to end this video, these are the only references that I use to do this document and this project. So I guess that's it. I hope you all like this explanation of my experiment and how did I do it. So goodbye and have a great day.